Alright, so we will continue working through our solutions of trig equations, and as always we want to start by figuring out which of the many strategies open to us should be used. So I always like to look first, are there any double angles or half angles? A double angle again looks like that, and a half angle looks like that. And I don't see that anywhere. You might say, isn't this a double angle? It's not. That's just theta. You are squaring, but you're not squaring the theta, you're squaring tangent. So that's not a double angle. So we're not going to use either of those. There may be a Pythagorean identity. We do have one involving tan squared, so we might come back to that. I don't see a greatest common factor. This has a tangent, that has a secant, so that's probably not going to work. There's no trinomial right now because trinomials have to have, like, both of these would be tangents or both of them would be secants. So that's not going to work, and that's not going to work. So we're down to 3 or 4, and let's look for the Pythagorean identity. The one that involves secant and tangent is this one. It's sec squared equals tan squared plus 1. So we're going to end up using this strategy. Now the question is, how do we know to use that strategy? And the answer is, when we're doing these problems, we want to only have to work with a single trig function. So we want to only have secants or only have tangents. It's too much, it's too difficult to have to work with multiple ones. So if you see multiple trig functions and one of them is being squared, that's a sign that you want to use strategy 3. See if there's an identity. Because if something's being squared, that's what the Pythagorean identities involve. They involve the trig functions being squared. So let's rewrite this as 0 equals 3 secant theta plus 3. And then I'm going to change tan squared. We'll solve it up here. So let's solve this one for tan squared by subtracting 1. So that means tan squared is equal to that. It's equal to sec squared minus 1. Okay, now when we simplify this, which we're going to do right now, when we simplify this, I'm going to put the sec squared in front. So I want you to try to guess what the next. Sometimes you have to use more than one strategy. So actually, I shouldn't have crossed off these first two because we might end up using more than one, and I'll tell you in advance that we will in this problem. So I'll put the sec squared in 1. Then we have 3 sec. That's going to come next. I'm writing this kind of in descending order of exponents, squared and then to the first power. And then 3 minus 1 gives us 2. Now look at those strategies. Which one does it look like? And hopefully you can tell it looks like a trinomial because you have something squared. Pretend that secant were x. This would be x squared. That would be like 3x, and that would be like 2. How does that factor right there? What multiplies to 2 and adds to 3? That would be 2 times 1 and 2 plus 1. So that means we can factor this right here in the same way. Instead of x plus 2, we can say secant plus 2. And instead of x plus 1, we could say secant plus 1. We're just going off of this pattern right here and replacing the x's with secants. Okay, so this equals 0. So now what we can do is set each part of this equal to 0 and solve it. So we'll make sec theta plus 2 equals 0. And we'll make sec theta plus 1 equals 0. So we'll subtract 2 from both sides there. And we will end up with sec equals negative 2. And over here, if we subtract 1 from both sides, we'll get sec equals negative 1. Okay, so now the question is, well, we're not as familiar with secant as we are with sine, cosine, and tangent. Which one goes with secant? And the answer is cosine. And cosine is the reciprocal of secant. So if secant is negative 2, cosine would be 1 over negative 2, or negative 1 over 2. Same thing over here. If secant is negative 1, cosine is a reciprocal of negative 1, which is still negative 1. Okay, so how do we find out what those angles are? Let's use a unit circle for the negative 1 part. Cosine is the x coordinate on the unit circle, and x is negative 1 right here. Unit circle means each of these radii are 1. Right here, x equals negative 1. How many degrees is that? It is at 180 degrees. So there's our first solution. 180 cosine and the secant of 180 is negative 1. Okay, negative 1/2, to get that one, let's use this table that we've used a lot for sine and cosine. And these go 30 and then 45 and then 60 degrees. And remember that the signs count up. Everything is root something over 2. So root 1 over 2, root 2 over 2, root 3 over 2. And the cosines count down. Okay, root 3 over 2, root 2 over 2, and the one that we're looking for is root 1. Root 1 is the same as 1, so 1 over 2. Okay, the only thing is this is negative, so we have a reference angle of 60, but a reference angle of 60 in quadrants where cosine is negative. And there are two such quadrants. This quadrant where sine is positive, this quadrant where tangent is positive. In both of those, cosine is negative. So this reference angle of 60 and this reference angle of 60, those are the angles we want. So this one is 180 except for that 60, 180 minus 60. That's the second quadrant angle, that's 120 degrees. And the other angle, this big angle plus that extra 60, so 180 plus that 60 would be 240 degrees. And that's our second angle for theta. So we have three solutions, 180, 120, and 240 are our three solutions to that problem.